Imagine this. You're walking alone at night. The street is quiet, almost too quiet. Your footsteps echo just a little louder than usual. Then you hear something else, another set of footsteps, slightly out of sync with yours. Not loud, not clear, but enough. Something changes instantly. Your heart speeds up before you even consciously notice the sound. Your breathing becomes shallow faster. Your shoulders tighten. Your eyes begin scanning without permission shadows, corners, movement. You didn't decide to do any of this. There was no meeting inside your head where you calmly discussed the situation and chose a response. It happened first. The explanation comes later. This is where we begin to understand something fundamental about the brain. It is not primarily a thinking machine. It is a survival machine. Deep inside your brain, there is a small structure called the amygdala. It's often described as a fear center, but that's a bit misleading. It's more like an early warning system, fast, crude, and biased toward caution. It doesn't ask, is this definitely dangerous? It asks, could this be dangerous? And if there's even a small chance it acts, signals are sent rapidly through your brain and body. Stress hormones like adrenaline and cortisol begin to flood your system. Your heart pumps faster to move blood to your muscles. Your breathing speeds up to bring in more oxygen. Your senses sharpen, not in a magical way, but in a selective way. You become tuned to anything that might confirm the presence of danger. At the same time, other systems are suppressed. Digestion slows down. Fine. Careful thinking becomes harder. Your attention narrows. You are no longer interested in abstract ideas or long-term plans. You are focused on one thing, survival in the next few seconds. Think of it like this. Your brain has a giant red button labeled, just in case. And the moment something uncertain appears, like those footsteps, that button gets pressed. What's fascinating is how little information is actually needed to trigger this response. The sound doesn't have to be clear. It doesn't have to be confirmed. It just has to be ambiguous enough. In fact, ambiguity is often more powerful than certainty. A clear, harmless sound can be ignored, but an unclear one keeps the system active because the brain cannot afford to assume safety too early. From an evolutionary point of view, this makes sense. If your ancestors ignored a rustle in the bushes that turned out to be nothing, they lost a few seconds of calm. But if they ignored a rustle that was actually a predator, they lost everything. So the system evolved to err on the side of false alarms. And that's the key idea. Your brain is designed to be wrong in a very specific direction. It would rather scare you unnecessarily than fail to scare you when it matters. So in that quiet street with those uncertain footsteps behind you, your brain is not being dramatic, it's being efficient. It is running a fast, rough calculation with incomplete data and choosing the option that maximizes your chances of staying alive. And all of this happens before you've even fully turned around. Now the sound stops. You turn around quickly, almost too quickly, and look into the darkness behind you. There is no one there, no movement, no shadow stepping out from behind a wall. Just an empty street, quiet again, as if nothing ever happened. At a conscious level, the situation seems resolved. The possible threat is gone. But something interesting happens next. Your body does not immediately return to normal. Your heart is still beating faster than it should. Your breathing is still slightly shallow. Your muscles remain tense, as if they are waiting for a signal that hasn't arrived yet. You might even feel a strange urge to keep looking around, to double check, to listen more carefully than before. Why? Because for your brain, the absence of evidence is not the same as evidence of absence. Just because you don't see anything now doesn't mean there was nothing there. And more importantly, it doesn't guarantee that nothing will appear in the next moment. So instead of shutting the system off, your brain shifts into a different mode. Not full panic, but not calm either, something in between. Think of it like a fire alarm that has stopped ringing, but the smell of smoke still lingers in the air. You don't just sit down and relax. You stay alert. You keep scanning. You wait for confirmation that everything is truly safe. This waiting period is crucial. Your brain is essentially asking a question. Was that really nothing? And it doesn't expect an immediate answer. Instead, it gathers more data. It listens for more sounds. It watches for patterns. It compares the current moment with what just happened, trying to find consistency. If everything remains quiet for long enough, the brain slowly begins to reduce the level of alertness. But long enough is not a fixed amount of time. It depends on context, past experience, and even personality. For some people, a few seconds is enough. For others, the feeling lingers for minutes, sometimes longer. What's important is that the brain is not simply reacting, it is evaluating, it is updating its internal model of the world. A moment ago, the model included a possible threat behind you. Now that model is uncertain, and uncertainty is uncomfortable for the brain. Certainty allows relaxation. Uncertainty demands caution. So the system stays partially active, not because it knows there is danger, but because it cannot confidently rule it out. This is where many people misunderstand their own reactions. They think, if there's no danger, why do I still feel this way? But the feeling is not a mistake. It's a reflection of incomplete information. Your brain is not waiting for proof that you are safe. It is waiting for enough evidence that it is safe to assume safety. And that is a much higher bar. Because assuming safety too early is the one error the system tries hardest to avoid. So even in the silence, even in the emptiness of that street, your brain continues its quiet work, checking, comparing, waiting, before it allows the body to fully let go. What follows is not a clean transition from fear to calm, but a gradual unwinding, more like a spinning top slowing down than a switch being turned off. When the initial threat signal fired, your body didn't just change direction, it accelerated. Chemicals like adrenaline and cortisol were released into your bloodstream, and those chemicals don't disappear the moment the situation changes. They continue circulating, continuing their effects, even after the reason for their release is gone. This is one of the simplest but most overlooked facts your brain can update faster than your body can. You turn around, see nothing. And at some level you understand that there is no immediate danger, but your heart doesn't instantly obey that conclusion. It keeps beating faster. Your breathing remains uneven. Your muscles stay partially contracted, as if holding on to a command that hasn't been fully canceled. It's like sending an urgent message through a system that doesn't have a perfect undo function. Imagine you press the accelerator in a car. The car moves forward. Now imagine you suddenly realize you don't need to move anymore. You take your foot off the pedal, but the car doesn't stop immediately. It keeps rolling. Momentum carries it forward. Your body works in a similar way. The go signal is strong and fast. The stop signal is slower and more gradual. Part of this is chemical. Hormones take time to break down and clear out of the system. But part of it is also structural. Your nervous system is layered with different circuits operating on different time scales. The faster, more primitive circuits trigger the initial reaction. The slower, more complex circuits evaluate and regulate it. And these systems don't always synchronize perfectly. So you end up in a strange state where your conscious mind has updated the situation, but your body is still catching up. You might notice small details: your hands still slightly clenched, your shoulders raised without realizing it, your attention still pulled toward every faint sound. Even though nothing is happening, your system behaves as if something might. This is not a malfunction. It is a feature of a system designed for survival, not comfort. If the body relaxed instantly every time a threat seemed to disappear, it would be vulnerable to sudden reappearance. A delay creates a buffer, a period of continued readiness, just in case the initial assessment was incomplete. There is also another subtle effect. When the threat stops, your brain doesn't just reduce activity, it begins a process of recalibration. It compares the intensity of the response with the actual outcome. It asks, in a very implicit way, was that level of reaction appropriate? But this comparison is not precise. The brain does not calculate exact probabilities or run clean equations. It works with patterns and approximations. So instead of sharply correcting itself, it slowly adjusts. This is why the return to calm often feels uneven. You might feel almost normal one moment, then suddenly notice your heart again or feel a brief surge of alertness for no clear reason. It's the system settling step by step, and during this settling, your awareness often becomes more noticeable. When everything is calm, You don't pay attention to your heartbeat or your breathing, but when those signals are slightly elevated, they enter your awareness, making the experience feel more intense than it actually is. So part of what you feel is not just the physical state, but your attention being drawn to it. The body is slowing down, the brain is updating, the system is stabilizing. But it does not happen all at once. It happens in layers over time, with small corrections rather than a single clean reset. Even after the obvious reaction begins to fade, something quieter continues underneath. You may find yourself turning your head again, listening more carefully than usual, not because you consciously believe there is danger, but because some part of your system is still not fully convinced. This is where the brain does something subtle and surprisingly sophisticated. It doesn't simply accept that the threat is gone, it begins to verify it, not once, but repeatedly. You hear a small sound and immediately compare it to the previous one. Is it similar? Is it different? You look into the same dark corner again, even though you already checked it. Your attention keeps returning to the place where uncertainty first appeared. This isn't irrational behavior. It's a kind of internal experiment. Your brain is testing its own conclusion. When something unexpected happens, like those footsteps, it disrupts your internal model of the world. A moment ago, your model was simple: the street is empty, the environment is safe. Then a new piece of information appears that doesn't fit. Now the model is unstable, and when the sound disappears, the brain doesn't immediately restore the old model. It doesn't fully trust it anymore. Instead, it enters a temporary phase of reevaluation. Think of your brain as constantly building a rough map of reality, not a perfect map, but a useful one. Most of the time, this map runs smoothly in the background. You don't notice it because it matches what you experience. But when something unusual happens, the map is questioned, and when the possible threat disappears, the brain doesn't just erase the event. It tries to understand it. Was it just a random noise? Was it something moving and then stopping? Could it happen again? These questions are not asked in words. They are expressed through attention. Your awareness becomes sharper, more selective. You begin to notice details you would normally ignore. The faint hum of distant traffic, the movement of leaves, the rhythm of your own footsteps. The brain is gathering data. It's looking for consistency. If the environment remains quiet, stable, and predictable, the brain slowly rebuilds confidence in its model. The street returns to being just a street. The shadows return to being just shadows. But this rebuilding is gradual. Because from the brain's perspective, it just made an error, or at least encountered uncertainty. And systems that deal with uncertainty don't rush back into confidence. They proceed carefully. This is why you may check the same thing multiple times. Not because you forgot what you saw, but because seeing it again provides additional confirmation. Each check slightly reduces uncertainty. There's also an important asymmetry here. It takes very little to introduce doubt into your model of reality, but it takes more evidence to remove that doubt. One ambiguous sound can trigger the entire chain of reactions, but the absence of sound must persist for some time before the system relaxes. This imbalance is not a flaw. It's a design choice shaped by survival. Because in a dangerous world, it is safer to remain cautious a little too long than to relax a little too soon. So what looks like overreaction or unnecessary checking is actually the brain doing exactly what it is built to do: testing, updating, and slowly restoring a sense of stability in a world that for a brief moment stopped making sense. At this point, something even more subtle begins to emerge, something that often goes unnoticed unless you pay very close attention. Your thoughts say one thing, your body says another. You might quietly tell yourself, there's nothing there, it's fine. The reasoning is clear. You turned around, you checked, you saw no one. The situation from a logical standpoint is resolved, and yet your body hasn't fully agreed. Your chest still feels slightly tight. Your breathing isn't completely steady. There's a faint tension in your muscles, as if they are still prepared to act. Your attention remains sharper than usual, ready to snap toward any new sound. This creates a kind of internal mismatch, not a dramatic conflict, but a subtle misalignment. One part of you has updated the model. Another part is still running the previous program. To understand this, it helps to stop thinking of the brain as a single unified system. It isn't. It's more like a collection of systems layered on top of each other, each with its own speed, its own priorities, and its own way of interpreting the world. The faster systems are built for immediate survival. They operate with very little information and make quick, rough decisions. They are responsible for the instant surge of fear, the tightening of muscles, the shift in attention. The slower systems are more deliberate. They process more information, consider context, and can override or adjust the initial reaction, but only after some delay. So when the threat disappears, the slower system updates first. It recognizes that there is no visible danger and begins to form a more accurate picture of the situation. But the faster system doesn't immediately stand down. It waits. It requires more evidence, more time, more consistency before it fully releases control. This is why you can intellectually understand that you are safe while still feeling as if you are not completely safe. The feeling is not simply a reflection of your thoughts. It is a reflection of the state of multiple systems that have not yet synchronized. And synchronization takes time. There is also an important detail here about how signals travel in the body. When the initial alarm was triggered, it set off a cascade, hormones released into the bloodstream, nerve signals sent across networks, physical changes distributed throughout the body. Reversing that cascade is not instantaneous. It's not like flipping a switch back to its original position. It's more like sending out a series of cancel messages that have to move through the same pathways, gradually reducing the intensity of the response. Some signals fade quickly, others persist longer, and while they persist, they continue to influence how you feel. There is also a feedback loop involved. When you notice your heart still beating fast or your body still tense, your brain can interpret those signals as evidence that something might still be wrong, not in a conscious verbal way, but in a subtle automatic way. So the body influences the brain just as the brain influences the body. This loop can keep the state of alertness slightly elevated, even in the absence of any real threat. But over time, as the signals weaken and no new evidence of danger appears, the systems begin to align again. Your breathing slows, your muscles loosen, your attention widens, the sense of urgency dissolves, and eventually the feeling of safety returns, but not as a sudden event, but as the result of many small adjustments finally settling into agreement. There is a deeper reason this process feels confusing from the inside. You experience yourself as a single, continuous you, a single point of awareness that thinks, feels, and decides. But the system producing that experience is not unified in that way. It is distributed. Different parts of the brain are doing different jobs at the same time, often without direct communication in the way we imagine. Some parts are generating emotional responses. Others are analyzing sensory input. Others are constructing a narrative that explains what is happening. And these processes do not always agree. When the threat signal stops, this lack of unity becomes more visible, if only briefly. One part of your brain says the situation is safe. Another part says stay alert. A third part tries to make sense of both signals and turn them into a coherent story. And the story usually sounds something like, I know I'm safe, but I still feel a bit uneasy. That sentence feels simple, but it hides a complex negotiation. The uneasiness is not an error in thinking. It is the presence of an ongoing process that has not yet completed. The system has not reached a stable conclusion, so it continues to run. The difficulty is that you are only directly aware of the final output, the feeling and the thought, not the underlying mechanisms producing them. It's like listening to the sound of an engine without seeing the moving parts inside. You hear changes in pitch and intensity, but you don't see the gears adjusting, the fuel being burned, the timing shifting. So you build a simplified explanation. I'm still scared. I'm overthinking. Something feels off. These explanations are not wrong, but they are incomplete. They compress a complex, layered process into a single label. And this is where human understanding struggles. We are very good at creating simple stories about our experiences. We are much less comfortable with systems that don't resolve cleanly. We prefer causes and effects that are clear and immediate. We like the idea that if the cause disappears, the effect should disappear with it. But the brain does not operate on that kind of simplicity. It operates on probabilities, delays, and feedback. When the threat disappears, the cause is removed, but the effects are still propagating through the system. Signals are still being processed. Predictions are still being updated. The body is still adjusting. From the inside, this feels like inconsistency. From the outside, it is exactly what you would expect from a complex adaptive system. There is also another layer to this. Your conscious awareness arrives slightly late to the process. By the time you notice that you feel uneasy, the underlying changes have already been happening for some time. By the time you think, now I'm calming down, the system has already begun that transition. So your sense of control is, in a way, delayed. You don't initiate most of these changes. You observe them, and then you explain them. This creates the illusion that your thoughts are directly controlling the state, when in reality they are often tracking it. This is not a flaw. It's simply how the system is organized, but it makes the experience harder to understand because the explanation comes after the fact. So when the threat signal stops and your body takes time to settle, it feels like something is wrong or inconsistent. In reality, what you are witnessing is a complex system gradually resolving uncertainty, with different parts moving at different speeds, and your awareness catching only the surface of that process as it unfolds. Even after the body begins to settle and the immediate tension fades, something quieter remains in the background. It's not the sharp alertness from before. It's softer, more diffuse, a slight uneasiness, a trace. Almost like the system is leaving a note for itself. Something happened here. This is where memory and emotion begin to blend. The event itself may have been brief, a few seconds of uncertainty, a sound that turned out to be nothing. But the brain does not treat it as nothing. It treats it as information, and information in the brain is rarely stored in a neutral way. It gets tagged, not with words, but with significance. That street, that moment, that particular pattern of sound, these elements become associated with a state of alertness, not strongly, not permanently, but enough to slightly change how they are processed next time. If you were to walk down the same street again, you might notice a subtle shift. You might pay a little more attention. You might be quicker to react to small sounds. You might feel a faint sense of familiarity. Even if you don't consciously recall the previous event, this is how the brain learns from uncertainty. It doesn't wait for clear outcomes. It doesn't require definite danger. It updates based on possibility. From a purely logical standpoint, this might seem inefficient. Why adjust your behavior for something that turned out to be harmless? But the brain is not optimizing for logical clarity. It is optimizing for survival across many uncertain situations. If a pattern has even a small chance of being associated with danger, it is given a slight weight. That weight influences future perception and reaction. Over time, these small adjustments accumulate, not in a dramatic way, but in a gradual shaping of how the world feels. Certain places feel a bit more tense. Certain sounds feel more noticeable. Certain situations trigger faster responses. This is not because the world has changed, but because your internal model of the world has been updated. And this model is always active. It is constantly predicting, comparing, and adjusting. So even when everything seems calm again, the system is not exactly the same as it was before. It has been modified, however, slightly by the experience. There is also an interesting asymmetry here. Strong, clear experiences are easy to remember and explain, but subtle ones, like a moment of uncertainty that resolved without consequence, are harder to pin down. You may not consciously remember the event in detail. You may not be able to describe it clearly, but the effect can still be present in how you feel and react. This is why sometimes a place can feel slightly uncomfortable without an obvious reason. The brain has stored something, but not in a form that is easily accessible to conscious thought. It's more like a shift in tuning than a recorded memory. And this tuning is constantly being updated. Every experience, especially those involving uncertainty, leaves a trace, not necessarily a clear imprint, but a small adjustment in the system. So when the threat signal stops, the process does not simply end. It transitions from immediate reaction to evaluation, to memory formation. And what remains is not fear, but sort of subtlety in how the brain interprets similar situations in the future. A quiet echo, not loud enough to dominate your experience, but present enough to influence it. Even as the initial rush of chemicals fades and the subtle traces of the event begin to settle, there is a deeper mystery that persists, something the brain does that we still do not fully understand. Humans like to believe we can fully map every reaction, every emotion, every flicker of attention. We assume that if we can measure hormones, record brain activity, or observe behavior, we can completely explain what happens when a threat signal stops. But the truth is far more complex. The brain is a layered, probabilistic system. It operates on predictions, constantly guessing what will happen next and updating those guesses when new information arrives. When a threat appears, it violates the current prediction. The brain responds immediately with heightened alertness. When the threat disappears, the brain does not simply revert to the previous state. It must process the mismatch between expectation and reality, recalibrate its predictions, and adjust multiple systems at once. This process is not linear, and it is not fully transparent even to our conscious awareness. One of the most puzzling aspects is the subjective experience. We can measure physiological signals, such as heart rate, pupil dilation, or hormone levels, but these do not fully explain what it feels like to transition from fear to safety. The feeling of lingering alertness, unease, or hyper-awareness is real, yet it emerges from interactions among countless neurons, networks, and chemical signals. The combination of feedback loops, different speeds of neural processing, and probabilistic updating creates an internal experience that is inherently difficult to articulate or reduce to simple cause and effect. Another factor is individual variability. Some people recover from a perceived threat almost instantly. Others remain tense or vigilant for minutes, hours, or even days. These differences are influenced by genetics, past experiences, current context, and the state of multiple interacting systems in the brain and body. Stress hormones, neural connectivity, attentional patterns, and memory circuits all play roles, but we do not yet know precisely how these components integrate to produce the unique subjective experience each person has. What is fascinating is that the brain seems to prioritize learning and adaptation over immediate comfort. Even when there is no longer danger, the system does not simply erase the event. It uses the experience to update its model of the world, adjusting predictions and fine-tuning responses for future encounters. The subtle persistence of alertness is part of this adaptive process. It may feel inconvenient or even irrational in a modern context, but evolution has shaped the system to be cautious, to prefer false alarms over missed threats, and to constantly refine its internal understanding of the environment. There is also the paradox of conscious awareness. Your thinking mind may understand that the threat is gone, but conscious awareness is only one part of the larger system. Many adjustments occur below the level of awareness. The body and brain continue to recalibrate even when the conscious mind believes the situation is fully resolved. This discrepancy between knowledge and feeling is why humans often struggle to explain their own reactions and why simple narratives, "I was scared, now I'm calm," fail to capture the full complexity of what actually occurs. In this way, the moment after a threat is removed becomes a window into the brain's most sophisticated operations: prediction, adaptation, integration, and learning. It is a moment that reveals not only how the brain manages uncertainty, but also how it constructs experience, shapes memory, and continuously updates the internal model that we perceive as reality. It is a process that is both measurable and mysterious, fully grounded in biology yet eluding complete explanation. Understanding this reminds us that what we feel is not simply a reaction to the outside world. It is a layered conversation inside, involving multiple systems, time scales, and feedback loops. It is a process that is adaptive, probabilistic, and deeply intelligent, even if we cannot yet fully describe or predict every detail. Even after the immediate threat is gone and the brain has begun its process of recalibration, there is another subtle, yet profound, layer to consider. The brain does not merely react and then return to a neutral baseline. It constantly updates its internal model of the world. incorporating both what happened and what could have happened. Every experience leaves a mark, even if it is brief and apparently insignificant. This is why even a small moment of uncertainty can subtly alter perception and behavior long after the event itself has passed. When a threat disappears, your brain engages in a quiet, continuous form of learning. It compares predictions with actual outcomes, evaluates the accuracy of its previous responses, and adjusts future responses accordingly. This is not done in a conscious, deliberate way. You do not sit down and analyze every detail. Instead, countless neural circuits engage simultaneously, communicating through electrical impulses and chemical signals, adjusting the internal landscape without any single system being fully aware of the whole process. The result is an updated brain that is slightly better prepared for similar situations in the future. This updating process is probabilistic, not deterministic. The brain does not simply catalog events in a rigid, fixed way. It weighs probabilities, evaluates uncertainties, and adjusts predictions based on past experience, current context, and incoming sensory data. If an ambiguous sound occurred once, the brain may slightly increase sensitivity to similar sounds in the future. If nothing harmful followed, it may decrease sensitivity slowly over time, but never entirely erase the trace of the experience. In this way, the brain maintains a constant tension between caution and efficiency. It seeks to optimize responses in an unpredictable world, rather than aiming for perfect relaxation after every potential threat. Memory formation also plays a crucial role in this process. Events associated with heightened alertness are often encoded more strongly, not just as discrete memories, but as patterns that influence perception and reaction. The brain tags certain situations, environments, or cues as potentially significant, which can alter responses in subtle ways. You may not consciously recall why a particular street feels slightly unsettling, or why a faint noise captures your attention, but your brain retains the imprint of prior experiences. This is why the aftereffects of a brief threat can persist beyond the conscious awareness of the event itself. There is also a fascinating interaction between the conscious mind and these underlying processes. Conscious awareness may recognize safety and attempt to rationalize feelings of lingering tension, but this reasoning is often lagging behind the adjustments happening in the subconscious systems. This temporal gap can create a sense of disconnect, making it feel as though the body and mind are not fully aligned. The conscious mind may interpret residual alertness as anxiety, worry, or overreaction. But from a physiological and neurological perspective, it is simply the brain and body completing a necessary process of adaptation and integration. The brain also operates through feedback loops where the body's state influences the brain's assessment, and the brain continues to influence the body. A slightly elevated heart rate or subtle muscular tension feeds back into the neural circuits, maintaining a heightened state until the feedback stabilizes. The same systems that heightened alertness now slowly attenuate it, guiding the body toward equilibrium while still keeping an adaptive margin of caution. Ultimately, when the threat signal stops, the brain does not just end a reaction. It engages in a layered, ongoing, and highly intelligent process of recalibration, learning, and prediction. It integrates sensory information, evaluates uncertainty, and updates both memory and perception. What you experience as lingering unease is not a flaw or an error, but the visible expression of a highly sophisticated, probabilistic system working to keep you prepared for an uncertain world. Even in calm, the brain is never truly idle. It is constantly refining its understanding, constructing reality, and preparing for the next moment, the next sound, the next potential threat. Even after the initial threat has passed, the brain continues its work in ways that are both subtle and profound. The experience of fear does not simply disappear the moment danger is gone. Instead, the brain engages in a process of reconstruction, prediction, and cautious calibration that influences not only how you feel in the moment, but how you perceive and react to similar situations in the future. The moment a threat disappears, the brain does not instantly declare safety. It first reassesses the situation, analyzing the sequence of events, sensory inputs, and context. This is not a conscious process, but an automatic, ongoing recalibration. The brain compares what it predicted would happen with what actually happened, updating internal models to reduce uncertainty in the future. Even though your conscious mind may recognize that there is no immediate danger, multiple systems within the brain are still actively verifying and adjusting their responses. Your body, for instance, may continue to exhibit signs of alertness long after the stimulus is gone. A slightly elevated heart rate, a subtle tightening of muscles, or shallow breathing can persist. These physical states feed back into the brain, creating a loop in which the system monitors itself for any sign that the threat might still be present or that a similar threat could emerge. This is why you might feel tense or hyper-aware even in the absence of any real danger. It is a reflection of the brain's cautious and adaptive design. Memory plays a crucial role in this ongoing process. Events that trigger fear or uncertainty are often encoded more strongly than neutral events, not just as explicit memories, but as patterns that shape perception and expectation. This means that even minor, seemingly inconsequential experiences can leave lasting traces in your brain's internal model. The next time you encounter a similar environment or stimulus, these subtle traces can influence how quickly you react, how alert you remain, and even how your body prepares for potential threats. The brain treats uncertainty seriously because uncertainty can be more dangerous than clearly defined situations. The process of returning to calm is therefore not simply a reversal of the initial reaction. It is a layered, multi-step procedure. The faster, more primitive neural circuits that triggered the initial fear response remain cautious and gradually attenuate their signals. Slower circuits responsible for reasoning, analysis, and prediction begin to align with these adjustments, integrating the sensory information and updating expectations for the immediate environment. The conscious mind observes and interprets these changes, but it is often one step behind the ongoing recalibration occurring at subconscious levels. This layered process creates a temporary mismatch between thought and sensation. You may intellectually understand that the threat is gone while still feeling residual tension or hypervigilance. This apparent discrepancy is not a flaw. It is a necessary feature of a system designed to manage uncertainty effectively. The brain prioritizes caution over convenience, survival over comfort, and probabilistic assessment over binary judgment. Even when the tension fully subsides, the brain has learned and updated. It has slightly adjusted its sensitivity, fine-tuned its predictions, and reinforced patterns of attention and awareness. This is why calm is not merely the absence of fear. It is the result of a sophisticated process of adaptation, prediction, and internal negotiation between multiple neural systems. What you experience as peace is in reality a dynamic equilibrium, a temporary resolution in an ongoing conversation between the body, the brain, and the world. Understanding this reveals a deeper truth about human experience. What we feel is never simply a reaction to external events. It is the result of a complex, adaptive system constantly constructing reality, learning from uncertainty, and preparing for the next unpredictable moment. Even in the absence of immediate threat, the brain is always active, always predicting, always negotiating with itself and with the environment, ensuring that you remain ready for whatever comes next.